Okay, so what I got here for the period was 1.3463 seconds using the equation that I showed to you, 2 pi square root of the length divided by g, right? Let's see if that's what we get for the simulation, right? Here we go. I'm going to put on the Earth. I'm going to pause. Let's pause that first. Here you go. Let's pause that first. Make sure you adjust the acceleration of gravity for the Earth. The length is going to be 0.45 meters and the mass 0.25. We're going to start at 30 degrees for the amplitude of my pendulum. Start my period here, my period timer, and start the simulation. Let's see if the period timer coincides with the calculated value. It's gonna go half oscillation, 3/4 of oscillation. Here you go, we got a full oscillation, 1.36. Let's compare 1.34. So there are 36, approximately 1.37, right? This one 1.35, so it's 2 out of 130. There is only a little bit less than 2%. That's what we have for this part. Okay. What is, you can skip that part here. What's the period on Earth of 7.5 kilogram pendulum with a length of 0.45 meters? Okay. Well, the length didn't change. The only thing that changed was the mass. Okay, and the acceleration of gravity remains the same. Everything is on Earth. So you should expect the same period that we got previously. And what happens as you increase the length of the pendulum? Let's take a look. As you increase the length of the pendulum, the period increases. The longer the length of the pendulum, the longer is the period. Okay? And that's what we have for this activity. If you want, you can also plot your graph. Let's plot the graphs. Here you go. Let's plot here the period against the length. See, the period increases. The period is here in the vertical, the length is here in the horizontal. The period increases with the length. The mass and the period. Here you go. I'm going to plot that. You're going to see it's not going to have much, yeah, the points are all over the place. Which, when you see a graph like that and the points are all over the place, it's an indication that there is no, the dependent variable doesn't depend at all of the independent variable, right? And then we can also plot this graph here, but for the period and the acceleration of gravity. Okay, it's better for this case. It's better if you paste the period here on the right side of the acceleration of gravity. There is a reason for that, and then you just delete. So the cell is going to shift to the left. Here you go. Let's plot period and G. Insert. Okay, so look here what happens. As the acceleration of gravity increases, the period decreases. Gets shorter and shorter. Okay? So that's what we have for this activity. Just keep in mind that the simple harmonic oscillator, the simple pendulum, is a very important device, and it was because of it that we are able to build more precise clocks. Okay, so I want to stop now, and I feel free to ask any questions.